Here we have a nice family of integrals. These are basically integrals of logarithm of trigonometric functions, log sin x, log cos x, log tan x, and the same. And limits are from 0 to pi by 2 in this side and 0 to pi by 4 in this side. Let's begin with the easy ones. So this is the easy one. We have integral equals to integral from 0 to pi by 2 of ln tan x. Now we will basically use King's rule over here. Now what King's rule says, it's necessary to know that as well. So King's rule basically says that if we have integral from a to b of f of x dx, this is equals to integral from a to b of f of a plus b minus x dx. Now why does this hold? If we take antiderivative, we have capital Fx going from a to b. Over here, we have capital F of a plus b minus x by minus 1 going from a to b. Now at b, this is minus fa, and then minus at a, this is minus fb. So this is fb, capital FB minus capital FA. This is also capital FB minus capital FA. So you can see that these two are actually equal. Yeah. Now let's go towards the solution. Over here we will use the King's rule. So that says that this integral will also be equals to integral from 0 to pi by 2 ln tan of, just add this, pi by 2 plus 0 minus x dx. Now this is integral from 0 to pi by 2 of ln cot x dx. So basically these two are same. So that implies these two are also same. Yeah. Okay, so no, not that. I thought this is integral from 0 to pi by 2 of ln cot x. I thought that. So I said it, but it's different. Yeah. Fine. Now these two are same. Yeah. And so if we add these two, we have 2i equals to integral from 0 to pi by 2 of ln tan x plus ln cot x. Yeah. And then dx. Now, okay, wow. Now, this is 2i equals to, we will use property of logarithms to bring these together, and that gives us tan times cot is 1 dx. Now ln1, ln1 is just 0 dx. So this integral is constant from 0 to pi by 2, which is c minus c, which is 0. So 2i is 0, that's why I is also 0. Yeah. Now this was this integral. It was just the use of King's rule, and that solved the problem. This integral is equals to 0. Now let's use another marker for another integral. Why? Because this is a family integral, so let's use a family of colors as well. Let's use this color. Okay. Now we will solve. Let's do, which one shall we do now? Now let's do ln tan x. Yeah, now that can be a good thing to do. Okay, now let's go to ln tan x. For this, what we can do is, if we just use King's rule over here, that will not make our life simpler, in fact. So we can do something like this. We can first let y equals tan x and see where do we get. And then tan inverse y is equals to x. So 1 by 1 plus y square dy is equals to dx. Yeah. After this, we will have integral from, sorry, we will have integral from 0 to 1. Then we will have ln y by 1 plus y square times dy. Dx is equals to this thing. Now we can use series expansion for this 1 plus y square. 1 by 1 plus 1 square. Yeah, let's do that. Okay, now for this, we know that since y is going from 0 to 1, the modulus of y is less than 1. That is why modulus of y square is less than 1, and modulus of minus y square will also be less than 1. So over here, it's something like integral from 0 to 1 ln y by 1 minus y square. So this is a symmetric ratio, which is why we can write this as integral from 0 to 1 ln y of sum of r going from 0 to infinity minus y square to the power r, and then dy. So it can be written as like in this form. Now extend the sum and integral. Extend the sum and integral. That gives us minus 1 to the power r ln y to the power 2r dy. Now this is just a gamma function. Yeah, this is some modification of gamma function, and it's not that hard to deal with. Yeah, it's not that hard to deal with. I will tell you one formula which can solve this. Yeah. Now the formula is something like this. Let me use another color formula, and I will write over here. The formula is integral from 0 to 1 of y to the power m ln y to the power n dy. This is minus 1 to the power n gamma n plus 1 by m plus 1 to the power n plus 1. So this is just a modification of gamma function actually. If substitute ln y as t, then you will get the gamma function eventually. So I will just use this formula for now, and you can just try it on your own. It's not that hard. Now let's proceed. So sum from r equals to 0 to infinity, and now this one is minus 1 to the power r, and minus 1 n is 1, and then we have gamma of n plus 1 is 2, by m plus 1 is 2r plus 1, n plus 1 is 2. Now we are left with this sum. Yeah, and this sum, let's see how it goes. R equals to 0 to infinity, and over here we have minus 1 to the power r plus 1, gamma 2 is just 1, and 2r plus 1 whole square. Now let's see how this sum is. At 0, this is minus 1. Minus 1 by 1 square plus 1 by 3 square minus 1 by 5 square. And it goes like this. And actually, if we take minus common, this sum over here is just the Catalan's constant. This sum is actually Catalan's constant that you can see. So it's actually minus g. Catalan's constant is represented by z, so this is minus z. So the answer is minus g. Okay, so answer for this integral is minus g. Now let's go to these integrals. Okay, sorry for that. Okay, again. And now let's go to these integrals. Let's change the color. Let's change the color, this color. Okay, now these two integrals are actually equal. Why? You can just use King's rule. If you use King's rule, you will see that this over here we can substitute pi by 2 minus x. So that's just cos x. So these two are actually equal. Now if so, we can say that 2i is equals to, if both of these are I, we can say that 2i is actually equals to integral from 0 to pi by 2 of ln sin x plus ln cos x. Yeah. Now this is again equals to 2i equals to integral from 0 to pi by 2. This will be ln sin x cos x. So that's just sin 2x by 2 dx. Now 2i equals to integral from 0 to pi by 2 of ln sin 2x dx minus integral from 0 to pi by 2 ln 2 dx. Yeah. Now over here you can substitute 2x as y, and from that 2 times 0 is 0, 2 times pi by 2 is pi, ln y, and then y dy equals 2 dx, so here dy by 2 minus, this is ln 2 times x, and over here in x that will be pi by 2 minus 0, so minus ln 2 times pi by 2. Yeah. Now this is the one that needs to be solved, this over here. So for that we can first take 1 by 2 outside, integral from 0 to pi by 2. Oh, it's not just y, it's ln sin y. Yeah, it's ln sin y. So ln sin y dy minus pi by 2 ln 2. Now the graph of ln sin y, let's try to draw that and we'll see something interesting. So over here, let's say this is pi by 2. Now the value of sin y, okay, so for this point in x-axis as well as this point, the value of sin y will be same, because sin y is positive here and here as well, and for any value that's pi by 2 plus x or pi by 2 minus x, the result will be same, because both of them will be just cos x. And since the values of sin y are less than 1 and logarithm of less than 1, they are negative, so both of them will have same value, same negative value. So actually the graph is symmetric about this point pi by 2. Yeah, and it goes negative infinity for 0 and pi, it goes negative infinity, but our idea is the graph is symmetric from pi by 2. So this area and this area will just be same. That's why we can write this integral as 2 times integral from 0 to pi by 2 of ln sin y dy minus pi by 2 ln 2. Now this integral is just I, we know, yeah, this integral is just I here, you can see that. Yeah, this is because this was this and the other one, the ln cos y were assumed as I. Yeah, so 2i equals to 2 cancels out, this is I minus pi by 2 ln 2. So I equals to minus pi by 2 ln 2. This is the solution. And here also the King's rule was used, and King's rule seems to be very important in most of these integrals, in this sort of integrals. And also we had to see symmetry, and that solved our problem. Okay, now this is minus pi by 2 ln 2. This is also minus pi by 2 ln 2. Now we have these two problems, these two integrals. This is 0 minus g. Yeah. Now let's use next color, yellow, the bright color. Yeah. And let's move. Okay. Now for these integrals as well, according to how we did for tan, we can just let these as y, and then and then we will have y equals sine x, sine inverse y equals to x, and then y by root under 1 minus y square. And in denominator, like over here, in denominator we will have something like ln y by root under 1 minus y square dy. And now you can use binomial expansion and so on, but that will be somehow tedious and long and does not give a neat answer. Yeah, so that's why we have an alternative approach. The approach is we can let I as integral from 0 to pi by 2 of ln sin x dx and j as integral from 0 to pi by 4 of ln cos x dx. If you do that, now I plus j is integral from 0 to pi by 4 of ln sin x plus ln cos x is ln sin x cos x, which is ln sin 2x by 2 dx. Now just what we can do is we can first use the property of logarithm to differentiate these, or let's say to make LA minus LB minus 0 to pi by 4 of ln 2 dx. Now for this, this is sin 2x. Yeah. Now what we can do is we can just change variable from 2x to y, and that gives us integral from 0 to pi by 2 of ln y and then dy by 2 minus over here this will be minus pi by 2 ln 2 times pi by 4. And now over here, this is not y, this is sin y, this is sin y. Okay, now this is a known integral. Yeah, now I plus j is equals to 1 by 2 of integral from 0 to pi by 2 ln sin y dy is just here. We already did that, and the answer is minus pi by 2 ln 2. Yeah, minus this is pi by 4 ln 2. So both of them are minus pi by 4 ln 2. So their sum will be minus pi by 2 ln 2. Yeah, so their sum is minus pi by 2 ln 2. Now let's use next color. And then now we will try to find the difference so that we can solve for both I and j. Yeah. Now let's try to find the difference. I minus j. That will be integral from 0 to pi by 4 ln sin x dx minus integral from 0 to pi by 4 of ln cos x dx. Now this is we will use the property of logarithms that gives ln sin x by cos x, which is why we have ln tan x dx. After this, this is already done. This is just minus z. Yeah, we did in the last problem. So most of these things are just interconnected. So that's why I brought up the family of these integrals. So I minus a is minus z. I plus j was minus pi by 4 ln 2. So that's why our I is minus pi by 4 ln 2 minus g by 2. We can just add both of them and divide by 2. And j is minus pi by 4 ln 2 plus g by 2. We can subtract the first from second and then divide by 2. So these are the answers, and we have finally solved all the members of the family. So this is minus pi by 4 ln 2 minus g by 2, and this is minus pi by 4 ln 2 plus g by 2. So these are the answers. We have cracked all of them, and hope you enjoyed the video. Thanks for watching. Like, share, subscribe, share with your friends, and yeah, look forward to seeing you in the next video.